All right. Oops. There we go. Don't want to hear myself on the audio inside. Okay, so as you can see, I basically did the exact same thing you guys did just during your lab activity today. I started fleshing out the overall form of my little bicycle here, and hopefully, as you start to get a little bit more experience in modeling, you'll start to understand why the importance of roughing out geometry is so critical to understanding the spatial relationships between all these little planes. Great example, the little front fork and what would be the back fork as well. It's actually not one down pipe in the back, okay? It forks out, just like I've done here, okay? Now, I very quickly fleshed out this back one, but how far does that fork need to go? There's actually two tubes that are going to terminate into one tube, like a fork, a Y, okay? From this rough layout, I can very quickly get to that end result, okay? I roughed out a very, very simple model of the tire. It's not done yet, but it's as far as I needed to go, right? I didn't do any of the spokes. I did some little nubs that went in the spokes, just to get an idea. But at the end of the day, I'm going to copy and paste that cylinder. Oops. And then it's going to move that one over here. Now from the top, because I flushed out the overall size of the tire, I can very accurately place the location of that downward tube, okay? So it's important that we work, and it looks like I'm actually a little bit too close here. This is why we want to rough out things, so we can start understanding how far these things need to go. Now, when I made a copy of that cylinder, you know, the new duplicate here is way, way too big. Did anyone stumble upon a way for me to like shrink this cylinder down, make it go like this, without changing its proportions?
Yeah, when you're using the resizing tool.
So the scale tool, right, absolutely. So the scale tool is a great tool. But at the moment, look at the action handles. Look where they're being placed inside the frame. If I was to scale this guy down, the action handles are going to scale this object globally, or to the global orientation of the XYZ axes. I don't want that. I would much rather have all my scale handles follow the angle of that tube. And it's an unknown angle. I really don't know what it is. Did anyone figure out how to do this? How to change the orientation of the action handles? Action centers, you got it. In Moto, the action centers are really the driver of how the tool handles are being displayed inside and how the tool handles are going to work and influence our model. So if I do selection, it's going to look at the selected piece of geometry and orientate my tool handles to follow the local angle of that tube. And now I can very, very easily start to get this shape where I want it to be. Okay, I can scale it down. Of course, I'm more than welcome to move it into position. This is where working to reference is really good. Maybe instead I just grab that bottom polygon and move it down because that's where it needs to go. This one's way too big. It needs to be kind of up here. And now within just a couple seconds, I've started to define the start of that down pipe and the beginning of that of the yoke, the Y bar on that back axle. Okay. Change your action centers. There's basically about 3 that you're going to use all the time. Of course, none is going to globally orientate your tool handles to the global orientation of the XYZ axes. Selection, and then I'm going to show you one a little bit later called element, which I think you guys are really going to like. Okay, those are the 3, and origin, so 4. There's really 4 that you're going to be using all the time. That way you can model with accuracy and with speed. Okay. Let's jump over to D2L and talk about specifically what we're going to be learning today and the application of all this new stuff. As you can see, your homework this week is going to be a house. One of my big goals in this class is to introduce everyone to as many different applications of 3D modeling as I possibly can. One of those applications is actually a booming industry, and that's the architectural visualization world. It's a natural pairing, 3D arts and the architecture world, right? It's a whole lot easier to build a model in 3D of a building, of a new skyscraper, a bridge, render it using our tools, and then use those renders as presentation artworks and concept artwork to show to our clients, right? It's really a powerful industry, and luckily for us, it's one of the low-hanging fruit, if you will, of the applications of 3D modeling in this the type of stuff that we're going to be doing. So this week we're going to practice making buildings. There are some techniques and some ideas that we need to look at specifically to ensure we're generating the most accurate result that we can. There's also some purpose-built tools inside of Moto that will help us get us to that end result as fast as we can. We'll come back and talk a little bit about the details of your assignment here in a minute, but the 10,000-yard description is you're making a house. It could be any house. I would encourage you to make your own house because you probably know pretty clearly the details of your own home. Okay? We'll come back to that at the end of class today. Yeah, absolutely. We're going to be making a small landscape, some trees, some bushes. I'll show you some presets that will help you create some trees and bushes pretty quickly. I'm a big believer that no one should really model trees and bushes. It's a waste of our time. It's a waste of my time. I don't want to model a tree. That's the silliest thing ever, right? I'd much rather go out and spend $10 on a pack of trees, all right? Because for $10, I can buy like 5 trees. Yeah, exactly. There are better ways to make trees than to model them. So, same with rocks. I hate modeling rocks. I'm just like, so I'm not going to model a rock ever again in my life. It's a waste of my time. I'd much rather go buy a model of a rock than model it, right? My price per hour is far more than someone's going to pay me to make a rock. So, yeah. Right. I'm sure there's some artist out there that's making bank on all these models that they're making, all these rock models that made, and more power to them. I say thumbs up for them. I hope they're very successful. Okay, let's jump back over to Moto and talk about what we need to look at in order for us to make our little house. Okay, as I mentioned before, there's some purpose-built tools inside of Moto that are specifically designed for architectural visualization. Now for your assignment this week, you're going to be modeling exclusively the exterior of your house. So you don't need to do the interior footprint, the interior floor plan of your house. I'm just concerned with the outside walls, okay? With that said, there's some tools that will help us get that footprint, that exterior footprint very, very easily. And let me show you what that is, okay? I'm in a new project file, and I'm going to look at my scene from the top. It's best to do what I'm about to do in an orthographic view from the top, okay? Believe it or not, the pen tool is going to be our guy here, and let me show you what I'm talking about. Let me go activate the pen tool. The pen tool, as we've learned from previous conversations, allows us to very quickly make custom shapes, right? This we know. This is pretty neat, okay? Each one of those locations, or each one of those little blue dots, is a control vert that we can continue to edit its location as we work, okay? But at the moment, this is still not exactly what we're after. Let me show you something here. There's an extension to the pen tool that is quite awesome, and I really like it. Let me refire the pen tool, and check it out. One of the categories of options that we have down here is wall mode. Let's do it real fast. Let's change wall mode, or let's activate wall mode by changing its setting to inner. And now we get to define the actual wall thickness. So that offset number is how thick your wall is going to be. Now, out in the real world, there's some very defined values on how big an exterior wall can be. There are building codes that establish exactly how big those exterior walls need to be, right? And I don't remember off the top of my head exactly what it is. My brain is saying it's 10 inches. That's the minimum wall thickness for an exterior wall. Now, I want to say like interior walls are like 5 or 6 or something like that. I don't know, but there are building codes and regulations that define this. Let's just use 10 inches as a starting point, okay? And then we'll build from there, okay? So I want to put inches in here. Now on your machines, if you're seeing like millimeters, okay, meters in this channel box, let me show you where you can go inside of your global Moto Preferences to get everything into inches and feet.
Where was that?
Where was what? So I'm in the pen tool. In the pen tool.
That's the pen tool?
That's the pen tool, the orange one that's selected up there in my toolbar, okay? Yeah, in Moto, our pen tool is very, very different from the pen tool that you're used to seeing over in like Photoshop or Illustrator. They're named the same, but the functions are very different. I'm going to travel to my global Moto Preferences real fast and get us into feet and inches, because for the majority of folks in here, that's the mindset that we're going to be working within. So if you go to the top of your screen here, under the black Moto pull-down menu, we have an option here called Preferences. These are our Moto Preferences. And then down at the bottom of this huge, long list, under the Input category, we have a subsection here for units. And if we click on it, check it out. At the top here, Unit System, I've changed mine from Standard Imperial or Metric to English, which gets everything into feet and inches. I wish the entire world would go to metric. It's so much better, right? You guys like metric? I love metric. I'm so tired of trying to figure out like how big 11/16 of an inch is, right? It just like boggles my mind. It's like, what is 7/8? It's like, okay, this makes me think way too much for simple measurements. I wish everything was in that power of 10 that metrics is, right? It's just so much better. It's like, how many millimeters are in centimeter? 10, right? How many centimeters are in a meter? 100, right? It's so much better. So much better. Powers of 10. I wish we in America would be smart enough to follow everyone else in the world, because we're everyone else in the world. We got to do our own thing, right? We got to drive on the right side of the road or the left side of the road, and then have our own thing. Anyway, okay. So feet and inches, And FYI, I want to draw this on the board real fast, just so everyone can see. I want to turn a light on so everyone can see exactly what the difference between feet and inches is. Okay, this is feet. Okay. So 10 feet, okay? So this equals feet. An apostrophe equals feet, okay? This quote, okay, open quote, is inches, okay? Inches, okay? So I'm going to simply enter it into my channel box here, 10 inches, to ensure that the actual geometry that I create follows the scale that I've established in that offset value channel box. Let's do it real fast. I think I'm good to go. Yep, good to go. Now, when I start clicking with the pen tool, check it out. Look what it does. It makes a quad strip for me. And I can very easily go in and define the layout of the exterior footprint of my house. In addition, with the pen tool active, notice that there's an option there. It's called Close. And that's going to close the loop and create an enclosed footprint like that. Now, while the pen tool is still on and active inside your scene, you're more than welcome and encouraged to go in and start messing around with these, find some good locations for them. In addition, let's talk about the differences between all the different wall modes. My value is set to inner right now, and look where the control vertices are in relationship to the outside wall of the house, right? The control point, the little blue dot, is on the inside of the house. The inner mode gets the control point on the inside. As one might imagine, if we change the wall mode from inner to outer, boop, now the control vertices are on the outside of the wall. Figure out which way makes it easier for you to make your shapes. Personally, I like inner. Okay, just jives well, a little bit better for how I'm working with things. But know that there's a difference. And lastly, and this is the dangerous one, is both sides. With the wall mode set to both sides, how big is my wall right now? 20 inches, right? It's double the size. If you look at it, we've gone 10 inches whoop, whoop, on either side. So now the total width of that wall is 20 inches. 20 inches. And the control point is here in the center. I'm not sure. It's in there for a reason. I don't know what that reason is. Personally, I almost always leave it set to inner and then do my thing. Okay? Maybe, yeah. All right. I want to drop the tool, and what we get, of course, at the end of the day, are always going to be true polygons. The pen tool has given us quad polygons that we can very easily use to create the footprint of our house. However, the one thing that the pen tool doesn't do is really give us, like 90-degree corners, okay? That's kind of an important thing for us in the architectural visualization world, right? Architects like to have, rooms that are generally square or have, some defined angles associated with them. So let me show you some options that we can enable to get that result. Because I want to be able to create a pretty square home with some accent walls. This time, I'm going to use my snapping engine to get me what I'm after. Where can I go to enable the snapping engine? We've talked about this in the past. Let's do it one more time. It is up the top of the screen, right? There's a big button that says snapping, and this is the global snapping engine. So the moment we turn this on, it's going to affect every single tool while the snapping engine is enabled. So it's right there. You guys remember the keyboard shortcut? X. X is the keyboard shortcut for the snapping engine. So X as in X-ray or xylophone. Okay? It's a good keyboard shortcut to commit to memory. Let me just turn it on here real fast by clicking on the button. Now, once our snapping engine is enabled, check it out. Down over here in our tool properties, we have all of our snapping options. So we globally enable and disable the engine, and then we can go in, oops, excuse me. There we go. Unpin that. Turned it off on accident. There we go. All right. So we globally enable and disable it, and then there are a whole series of options that will allow us to go in and tell the computer what or where to snap all of our tool handles and edit points along. Right now, I'm doing a little grid snapping, which is pretty cool. I'm also snapping to some vertices. But if you go down to the bottom here, this is where it gets a little bit more interesting, especially through the lens of architectural visualization, because now we can snap to world axis, straight lines, okay, and right angles. Let's enable all three of those. I think for the context of this conversation, we're going to turn off grid and turn off vertex, but enable world axis, snap, straight line, and a rectangle. Let's do it. Now, when I fire off the pen tool, yeah, see how it snaps to a straight line? Boom. Love it. And when I put a control point over here, it's very difficult to see, and for that I apologize. It's a light, light, light purple line. See if I can make another one here. Yeah. Okay, look down. You see in the corners of my square? It's very difficult, and I apologize. You see those little light purple squares? What's that represent? 90-degree angles. You got it, right angles. So that right angle snap is doing its job. Now we can very quickly go in and craft something that's got some really neat work associated with it. All right. Makes working with the pen tool, especially when building homes, very, very quick. All right. So there's my little house. It's a pretty good looking house. However, how big is it? Total area. Does anyone have an idea? It's probably not very big, right? Is there a way that we can easily figure out how big the footprint for my home is, the total footprint? So there's a couple ways we can do it, right? As we've talked about in the past, this number down here in the bottom right-hand corner of our OpenGL viewport tells us what? It says 12 inches. What does that represent? So I'm looking down here. It says 12 inches. Right now, that number denotes how big each one of the grid squares are currently sized inside of my scene. So I could go in, so each grid square right now is a foot, right? So I can go in and I can go like 1, 2, 3. I'm not going to count it because that's way too much thinking for me. I don't count, right?
Each large block 100 squares?
If we were to count, probably, is it 10 by 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so 10 by 10, 100 squares.
If I was following what you're doing, why does mine say 12 inches? I mean 6 inches.
So it's a good question. Yeah, so this grid is dynamic based on how far we've zoomed in or zoomed out of our scene. So if I continue to zoom in, now mine says 6 inches. If I zoom out, now it says 20 feet. Okay? Yes, sir?
How did you make it so that when you start creating a polygon, it's on the base, it's on the 0 of the y-axis?
So I was looking at my scene from the top when I initially did the pen tool.
But it still doesn't like a distance above the actual just origin.
Okay.
I don't know why it does it.
It doesn't matter where it gets initially created, because we have the power to move it where we want it to go, right? How can we move that entire surface down to the XZ plane?
Switch the things on the left and to make it so that, or the move tool.
Move tool is not going to give us the accuracy that we want. I think I heard someone say it. Center selected, absolutely. Select that plane and then center it, probably just exclusively along the Y. That will get us down there. Okay. Okay. So let's figure out if there's a way for us to very quickly gauge how big my house is. Because this is supposed to be a house, but I have a hunch this is more like a closet size. Check this out. This is actually really neat. Moto has a really great dimensions tool that will tell us how big our selection is. You can find that dimensions tool under the View pull-down menu, and it's right there, Dimensions tool. If we turn it on, check it out. Yes, now it's telling me exactly how large the total area of my home footprint is. It's 17 feet, 8.1 inches kind of long, and then 13 feet roughly wide. Okay, so it's not exactly the biggest house on the face of the planet. Let's change it. It's under the View pull-down menu at the top of the screen. It's called the Dimensions tool. I'm just going to move these around a little bit. Yeah. A little fun little bay window here. So it's not exactly the most stimulating home on the face of the planet, but that's okay. All right, there it is. There's my footprint. I've made some changes, and I'm really happy with the overall size of my house. Let's turn off the Dimensions tool, okay? And now the next step is to go ahead and center this inside of the origin, right? We always want to ensure that our house is centered around the origin of the scene, okay? That continues to be the critical modeling location for basically all models that we do, right? Because our workflow, the future application of tools, is easier when everything's around the origin. All right, so we've defined the exterior footprint. What's next? Now we got to start raising the roof, baby, right? Start bringing the walls up. Check it out. This is awesome. What tool can I use to raise my walls? Yeah, extrude is fine. What's the other alternative? Bevel. Both will give you the exact same thing. 6 to 1, half a dozen to another. Pick your flavor of choice. Let's just bevel this up. However, check it out. Now I'm using the bevel tool, but pay attention to scale. Just don't bevel it until you think it's an appropriate height. We can do this to scale. How high? Imagine you're sitting at home. Okay. How high is the ceiling in your house? Yeah, it's going to be one of three things. Luckily, the construction industry is standardized. There are standard sizes for a lot of these things. The ceiling in your house is probably going to be 8, 10, or 12 feet high. Okay? So let's make this, I don't know, let's make it a 10-foot tall ceiling. So I could physically go into my channel box here, 10 feet, hit the Enter key on my keyboard, and then boom. Now I know beyond any reasonable doubt that those walls are 10 feet tall. When using the real-world measuring system inside of Moto, building models to scale is really, really easy. Okay, so I have the walls of my house. What's the next step? We got to make a roof, right? We got to put a hat on this thing. So let's go ahead and make a roof. Now, making roofs is not difficult, but it isn't easy either, because there's a couple things in here that we need to establish. Let's look at my scene from the front. Okay? I'm going to put a door in there at one point, but I want to ensure that the center line, the ridge line of my roof, is perfectly centered at the origin of the scene. That is a critical piece. Got to have it, okay? We also need to define the pitch, the angle of our roof. How could we do this quickly and easily? Let me show you a really great idea. For me, whenever I'm defining the pitch of a roof, I always start with a cube. Roofs are generally flat, right? So the initial application of the cube tool makes sense. Let's do it real fast. Just going to go in. Now, just don't draw any shape. Pay attention to the details. Pay attention to the size of my roof. Right now, my roof's thickness is 30 inches. That's like this big. That's a pretty thick roof. Nothing's getting through. That's like tornado-proof roof, right? On average, how thick do you think your roof is? On average, take a guess. 5 inches, that's a good guess. So right around there. Every roof is going to be slightly different. I spent an entire summer when I was 18 being a roofer or working for a roofing company. It was the worst summer of my life. I hated every single moment of being a roofer. It was not fun, and I'm not going to do it again, right? It was a horrible experience for me, but I learned a tremendous amount about how a roof is constructed and all the different layers that go into it. If you think about it, and of course we have all the shakes and the shingles. Now, depending on what product that you get, they're going to be anywhere between 1/4 inch and 1/2 inch in size. Okay, then there's going to be an underlayment, some sort of tar paper or some sort of vapor barrier that acts as a waterproofing agent. And then all of that is basically nailed to a piece of 1/2 inch or 3/4 inch ply. So really, your roof is only about that much, okay? At the end of the day, it's not very big. There's not a whole lot of material up there that keeps all the elements out, okay? And then the joist. So and that's why I say about 5 inches, because if you take a 2x4, put it up, that's about 3.5 inches, 5/8, whatever it is, and then you add another inch or so, a couple inches, so about 5 inches. That's a good starting point for the thickness of our roof. So we don't want 30 inches. Let's put 5 inches. Not 4, 5 inches. There we go. Hit the enter key on your keyboard. And now we're very quickly starting to define the width and the size of our roof. Let's center this thing along the x-axis. There we go. So that everything is centered around the origin of the scene. Now we need to create a ridge line. Now creating ridge lines is not difficult. This is the peak of the roof, okay? At the very least, there are some zero elevation roofs out there, but most places, this building is a great example, has a very nice defined pitch, so all the water runs off, okay? So we need a center point. How could we very easily take this cube and infuse a center line on our roof? You could do a loop slice. Let's give it a try. Let's see what happens. Now, right now, we're working with a single polygon. So the loop slice may or may not give us what we want, but let's give it a try. It's a nice idea. Mode of uniform, count of 1, and it did it. Awesome. So now I got one right down there in the center. What's another way of very quickly infusing an edge right in the center of my roof? The traditional slice tool is a great idea. That's probably what I would have done. Now, one of the issues that may arise as you're slicing this, is that you may not get, and I'm going to zoom in here to make it real easy. If we use traditional slice, if you're just ever so slightly off, if you don't draw a perfectly vertical line, that's what you're going to get, right? A diagonal edge right smack dab inside that polygon. I need this edge to be perfectly vertical. How can I do that? Absolutely. So we absolutely need to we could hold control when we did the slice. That draws it'll constrain the slice tool to only slicing horizontally and vertically. But what if we didn't do that? Let's pretend that we thought we had, but this is actually the result that we got. How do we get this nice and straight? The snapping tool, there's an easier way than the snapping tool. Let me show you a great trick, okay? This is the fastest way to take this edge and get it to be a straight line, okay? What you don't want to do is do center selected, right? Because watch what happens. Center selected along the X. No, I didn't really move it. Let me really push it away. There we go. Now I'll do center selected on the edge, on the X. Did it make it vertical? No, it moved all the components that we had selected together as a group. So the vertices on either side of the edge were moved together as a unit. I need them to do this, bloop, into a straight line. I need the computer to interpret these vertices and influence them independently. So there's 2 ways that we can go about doing it. One way is to travel over to our vertex collection of tools right here and set position. Set position is going to treat each vertice within the component selection individually. We'll get a popover. And what this popover is saying here is saying, hey, define a location. It's a little confusing because the value is in feet. So you think you're moving at a defined distance. No, this is a location within the scene. If I leave it at a value of 0, where are these 2 verts? going to go? The origin, right? Watch what happens now when I hit OK. Bloop. They both move. Great tool. I use set position a lot. Let me show you the other alternative, and you're going to hate me. It's using the scale tool. And check this action out. Just grab this handle, scale it to a value of 0%, makes it straight. Two ways of doing the exact same thing. Okay, now that we have a center line for our roof, we get to start establishing where we want this roof to go. And I'm just going to get this into position here very quickly. Somewhere right around there. There we go. And now I want to grab the ridge line. And this is how easy it is. Just move it up. Whoop. Awesome. Roof completed. Now it's a two-dimensional plane, so we need to do some extrusion here. So I'll grab that profile, Shift X, and begin to center it and put my ridge line, or excuse me, my roof elements where I want them to go. Maybe I want to have some sort of overhang, some sort of porch in the back, perhaps. Place for my barbecue, because Pat does love me barbecue. Yes, sir.
You did that with the slice tool?
Did what with the slice tool?
Putting it through the middle to on the roof and bring it out?
Absolutely. The slice tool will give you that edge, because you need to have an edge in the center of that polygon to create the ridge line for your house. All right. However, we have some editing here that we need to do. I extruded it. And I extruded it so we had a polygon on both sides. Now we have some editing in here that we need to do. Specifically, if you look at the roof line from the house, man, this eave, this overhang is way, way too big, right? Think out to, if you were to go outside and look up at the eaves of the roof outside this building, our eaves are not that far away from the house. That's a pretty long distance, right? On average, they're probably going to be anywhere between 18 and 24 inches away from the house. That way, when the rain comes off the roof, it doesn't fall directly next to the walls of your home. It falls a little bit further away. So this is way too big, but I need to move it, right? I want to move that polygon where it needs to go. It's way too big, but at the moment, with my action centers turned off, look at the orientation of this tool handle. I need to move it along the x-axis to get that polygon closer to the house, maybe somewhere right around in here. But when I move it as is, man, I'm changing the angle of the roof. I don't want to do that, okay? I really enjoy the angle of my roof. I want to be able to move this polygon along that surface right there. On the surface, it feels like we just maybe use the selection action center to get what we want, but that polygon is perfectly vertical along the global XYZ axis. So let me show you a new one. Okay? Even with the selection action center, the problem still persists. There's an action center in here that I use a lot, and it's fantastic. And it's an action center that I wish all 3D apps had, because it really is quite special and makes my job as an artist quite easy. It's called the Element Action Center. With the Element Action Center, we get to define the orientation of our tool handles based on the orientation of another piece of 3D geometry. Let me show you how it works just one time, and then I think you'll probably understand it. So notice that I have the Move tool turned on, and I'm going to change my Action Center from Selection to Element. Now on the surface, it feels like the Move tool has been disabled, but look at your tool pipe over here. It's still on. It says Transform tool. Okay? What the Element Action Center requires is a selection. You have to go in and tell it to, there it is, way down over here. You have to go in and tell it to align its action handles to an existing edge or polygon within inside of your scene. So I'm just going to grab that edge right there. You can see how the tool handles immediately just pop in to that area. And now we have one axis that's shooting up and down the selected edge component. And I can just bring in that polygon until I'm happy with its position. And I no longer have to worry about that edit affecting the pitch of my roof. Yeah?
Does it matter which way your arrow is facing?
It doesn't. Mine, the green one was kind of shooting down the roof. If yours is a different... if a different color is shooting down the roof, that's fine. Yeah, we just need to have one of those tool handles shooting down the angle of the roof. It's pretty great. I really enjoy the element action center. Now I want to have my roof be symmetrical, so I think I'm going to just mirror my roof real fast. Action center set to origin, duplicate, mirror. There we go. Now I have a symmetrical roof. All right. Yes?
When I did that, now it's lined up on the roof, but when I went to move it, it's moving everything in the scene.
Make sure just make sure you have the polygon that you want to move selected. Okay?
Before you fire that up?
Before, yeah. Yep. I had that end polygon selected. I fired off the move tool. I changed my action center to element and clicked on the edge that represented the angle that I wanted to move that polygon along. And then the tool handle's oriented to the angle just quite perfectly. Yes, sir?
Bringing the wall at an angle to meet the roof.
That's the next challenge, right? Because if you look at our house, we have the world's best air conditioning system going on right now, right? A little bit of a challenge going forward, okay? We need to fill the hole between the top of the roof and our walls, okay? Yes, go ahead.
When doing that, it's taking that and going like this.
Okay, let's see what's going on. Okay, go ahead and drop your selection. Now you're selecting the wrong one. You want to select this polygon over here.
This one?
Go into perspective for a second.
Oh, the one
On the end, yeah, you got it. The cap on the end. So it'd be this one, this long one.
This.
No, it'd be that one. That one, right? That's the one. Yep. That's the one you want to move. Yep. And now fire off the move tool. You can actually do it from here. Fire off the move tool. Now click on that one right there. Perfect. Yep. Or try clicking on the edge. That one. Yes, there we go. Now, yeah. Now your snapping engine's on, so that's kind of influencing how far it's going. It's just going to do the one side, which is why I deleted the other half and mirrored my roof so I had duplicate identical copies on either side. Okay, let's keep cruising because there's one final thing here that I want to talk about, okay? And it's an application of a really neat system, a system that we're going to be building on for a couple weeks. It's called Booleans, okay? Booleans are quite awesome because what we have here is a very solvable problem when we use the Boolean tool, okay? If we were to, so I have to have the walls of my house perfectly match the underside of my roof. Now, I don't know what that angle is. I don't know what the distances are. It's a little bit of a challenge for me. So here, I could do this. I could slice this along the ridge line like that and then start maybe, I don't know, moving some of those edges up and kind of hoping for the best, whoops, kind of hoping for the best here. Start burying them in. But this, oh man, this one over here is going to be problematic and it's never going to look good and that's just not going to work. That's not going to work. Let me show you what the secret is. It's called Booleans. I'm going to go back in time a couple steps here. And what we're going to do is that we're going to use the roof as a cutter. The roof is going to slice my walls. Now it's pretty cool. There is a defined order of operations here that we need to follow. Okay, so put this in your notes. Watch the live stream after class. This is an important order of operations. If you don't do this, the Boolean system just isn't going to give you the results that we're after. The Boolean system is a mesh item to mesh item slicing system. So I need to separate the roof of my house onto its own mesh item and have the walls on its own mesh item. Okay? Let's just do that real fast. I want to rename the mesh item that I'm currently working on to walls. There we go. And I'll hit the N key on my keyboard to create a new empty mesh item and rename that one to roof. Okay? I'm I'm going to go back to my walls mesh item that contains all the geometry in my scene, grab my roof, and I'll do edit, cut, go back to my empty roof mesh item, and do edit, paste. Okay? So that's step number one. We have to separate out all the cutting geometry into its own mesh item. Okay? So I just want to have my roof on its own mesh item and the walls on its own mesh item. Okay, now the next thing that we need to do is return to our walls. And I'm going to grab just that top loop of polys. And here's the next thing that we have to do. We physically have to move our walls so that they cross all the way through our roof. That's the second required element. The geometry needs to cross each other. Okay? Let me just fire off the move tool here real fast and raise my walls until they physically cross through the roof. Okay? So if you take a look at it, we're basically creating a gigantic cookie cutter with our roof. The area of our walls that are above the roof, we're ultimately going to delete. Okay? We're only doing that to ensure that the Boolean tools work correctly, and then we'll delete it after the fact. Okay? I saw a question. I answered. Okay, great. So with that done, now we can go in and fire off the Boolean operation. Make sure nothing is selected in your scene. Yeah, go ahead, Rob. Question? So the critical step is that we need to make sure that the walls are physically higher than the roof. Okay, and I mean by a good portion, because the roof is going to turn into a cookie cutter. A big cookie cutter. I've just moved mine up, and as I navigate around the scene here, you can see what I've gotten. And this is the product of a previous slice that I no longer need. All right. The next step, and this is the third sequential part of our procedure, is that we need to ensure that the geometry that's going to do the cutting, so in our case the roof, is in the background, and I'll put that in finger quotes, in the background of our Moto scene. Basically what that translates into is that the roof needs to be unselected. If you look at my item list, the walls are the only selected item. This is an item-to-item operation. The background geometry, the unselected items, are going to be cutting and slicing the foreground items, or the selected item, okay? I think once you see it in practice, you'll probably go, oh, I got it, okay? So let's do it real quick. I got my walls selected, and now we can find all of our Boolean tools under the Geometry pull-down menu. So at the top of the screen, Geometry, and they're way down here at the bottom. And we have three different Boolean operators. We have axis drill, solid drill, and Boolean. Each have their own conditions. Each have their own sub-operations. I find that solid drill gives me the best benefit because it puts me into the driver's seat as to what I can do next. Okay? If you haven't noticed by now, I'm a control freak. I really am. So solid drill gives me the control over the next modeling stage. So let's do it. We'll do solid drill. And now we'll get this popover. Inside of this menu, we have to tell the computer which type of solid drill operation we're going to do. I'm going to choose slice because I want to slice my walls with my roof. And then the driver mesh is going to be the background mesh items. So in our case, the roof. Let's zoom out, hit OK. You can see that mission successful. If you look at my walls, the roof, let me turn the visibility of my roof off. There it is. The roof has been used as a slicing guide for the Boolean operation. If I turn the roof back on, you can see that the angle of my slice perfectly matches the roof line. With that done, I can go back into my walls, grab this top loop. I want to hit the Shift up arrow 2 times, hit the delete key. And there it is. I now have all of my walls perfectly aligned, perfectly to the pitch of my roof. Okay? No guesswork. You know, I didn't have to, there's no dragging of vertices in here. We're using one mesh item to slice another mesh item. Thank you. Let's do this one more time, because practice makes perfect. Okay? So we have the roof, but what about the windows? Think back to your own home, your own apartment building. The windows often are defined sizes. There's industry standard sizes. You know, unless you have a really kind of oddly shaped house, maybe you'll have some custom windows. But I have a long wall in my home, and every single window along that wall is exactly the same size. Okay, I don't want to have to guess as to what that size or try to individually model each window. Perhaps I can use this Boolean operation to get us where we're after. Let's do it again real fast. I'm going to create a new mesh item. And on that new mesh item, I'm going to very quickly flesh out the shape of a window, which is just a cube. That's all it is, right? Windows are just squares. Now, pay attention down here to the size of your window. My window is 4 feet 3 inches by, let's just make it a 4 foot by 6 foot window. So it's a big window. That's like a gigantic window. Let's make it 4 feet tall by 3 feet. Oops, there we go, 36 inches. There it is. All right, so now I'm going to extrude this plane out so that it physically crosses the walls of my house. Physically crosses both sides, both the inside and the outside. And now I've defined where I want that window to go. Okay? It's just a cube, that's all it is. A cube that goes through the entirety of the wall that I'm trying to slice it into. Maybe I want 3 or 4 windows in the front of my house. Well, I can simply maybe use the duplication tools to clone this cube across the front plane of my house. So let's do clone. Now I have 4 windows. Yeah, sure, why not? That's good. I'll drop the tool and we're on our way. Okay? So in every sense, these cubes are going to be the cutters for my wall, much like the roof was the cutter for my walls a moment ago. Let's run the Boolean operation one more time. This time, I'm going to turn off the roof and only have the mesh item that contains my window cutters visible inside of my scene. Things are looking good, so I'll go to the top of the screen where it says Geometry. We'll go to the Boolean operators, Solid Drill, and then I'll use Slice one more time. Bloop. And it's done it. It's sliced through, and I'm ready to rock and roll. I'm sorry, say again?
I'm trying to follow that, since I'm just not as fast as you are. I'm like lagging.
That's okay. Well, everything is looking good so far, right?
Yeah.
So you got your windows. The only thing that I've done differently is that I've turned off the mesh item from my roof. Yep. Now run the Boolean, and you're good to go.
Why do you need to disable the roof?
I disabled the roof because it was technically still in the background, right? Yeah. Moto's going to use all background items to influence the Boolean operation. But
those cubes weren't touching the roof at all.
They weren't, but the computer was still going to look at the roof polygons and see what it could slice based off of that. So the rule of thumb is turn off everything but what you're trying to cut, in my case the walls, and what is going to be cutting the walls. Turn everything else off.
Like if you had the roof on, it would be cutting vertically also?
I don't think I follow.
Like the roof is okay, you have the cube right here, and the roof is like right here.
Mm-hmm.
Would it just do it vertically also?
No. No.
I'm just not understanding.
And also why there's lines between the groups.
I'm sorry, say again?
Why there's lines between the groups.
Yeah, so all these and all these guys. The computer's trying to connect all of these n-gons together. It's trying to do its best to make a compliant surface. With architectural visualization, with flat, planar surfaces, we can use n-gons. It's okay. We don't have to slice everything into quads. We can get away with it with this type of project. It actually makes it go a whole lot faster. This is not going to be a subdivision surface model. It doesn't need to be, nor should it be a subdivision surface model. The distance that we're going to be rendering our shapes, or the distance we're going to be making our pictures from the house itself, we're not going to take take advantage of the subdivision surface algorithm. Okay, this is not a curved surface, so it doesn't need to be a sub D. A planar shape is going to be sufficient. So now that we have all these little squares in here, I'm in control of the next step. Let me show you something. This is how to create a window 101. Okay, I have a whole bunch of squares that I need to make openings for. When you're doing this type of work, try to place yourself in the shoes of the person that actually makes a house, okay? Because when you're framing a house like this, you're going to create openings for windows, and then a window, basically a window frame, okay? Or excuse me, a window casing, and then a window is going to be placed inside that casing, and then the window is going to be trimmed out to hide all the unfinished areas of the window, okay? So here's what you could do, and let me show you what I'm talking about. You could go in and maybe delete that polygon, basically delete the interiors of these. Then, if you look at the opening here, we're left with an invisible hole. So how would I connect those two openings here? Bridge, absolutely. Bridge is a great thing to use in this particular application. And there it is. Now we have the illusion of a thickness, of the window opening inside of our walls. Yeah. So here's what I did. I just deleted both sides of the square, of the opening, went into edge mode, double click, shift, double click, basically selecting both the edge loops that comprise the opening of the window, and I ran bridge. Whoop. Here's another great application of the bridge workflow. I'm not going to delete the polygons initially. Check this action out. Bridge is a pretty intelligent tool. It's one of the best tools inside of Moto, in my opinion. Instead of deleting the polygons this time, I'm going to select them as is, okay? And I'm just going to run bridge. Check this action out. Bloop. Save you a couple steps, which is nice. Yeah, let me do it one more time. I'll grab that one, and I'll bridge them. Bloop. Pretty cool. Yeah, it's cool. Bridge is pretty intelligent. Okay, so now let's go in and start using this structure to continue making all of the other elements of a window, because the more details that we infuse in the window model, the more real it's going to believe. Okay, the more real it's going to feel, excuse me. So now we need to actually go in and make the actual window frame itself. And if you look at maybe the window to my office over here, it's not that complex of a shape. It's really just an additional rectangle on the inside of the window and then a pane of glass. We can do all of this relatively easily and quickly, maybe just using loop slice. I'm going to grab two polygons around the loop for that one opening. I'll run loop slice, Alt-C, with a count of 2 and a mode of symmetry. Now I can define the thickness of my window. Maybe somewhere right around in there. That's good for me. I'm going to grab that loop, the new loop that I just created, and now I'm going to bevel it. And I'm going to pay very close attention to how far I'm beveling outwards in this shift. I'm doing 2 inches, and that's a good kind of thickness for a window frame. There we go. Awesome. Drop the tool, drop the selection, and it's starting to look a little bit more like a window. So we have the window frame. Now we need to create the individual panes of glass that go on the inside of windows. Most modern windows are double paned, meaning there's a small section of air in between each panes of glass. Why do we have that? Does anyone know? Insulation. The air is going to help. The air that's trapped in between the two window panes helps keep all the cold air out and the hot air in, right? It's insulation. It's kind of really fancy, low-tech insulation for our windows, okay? So here's another thing we can do. I'm just going to do loop slice once again, count of 2, mode of symmetry, and I'm just going to place it maybe right in there. What I'm after is basically that edge loop there and its counterpart that we just created. And here's what we're going to do. We're going to select both of those new edge loops individually and just fill them with a polygon. Now, the first one that you do is going to be flipped the wrong way. So I'll hit the F key to flip it its other direction. Whoops, excuse me, zoomed in too far. We're basically creating geometry. Hit the P key again. We're basically creating geometry for the outside of the window and the inside of the window. We want to have geometry for both the outside and the inside so that when we go and render this next week, we can recreate the correct reflection and refraction of glass. Okay? Really is that simple. Let me do it one more time so you guys can see what it looks like. I'll do it on this one. Select 2 polygons on that inside loop, loop slice. Count of 2, mode of symmetry. I'll hit the L key, grab that one, bevel it up 2 inches. I'll shift it 2 inches. I'll loop slice that again, then grab those 2 new edges that I just created, and then fill them with a polygon. Flip that one. The first one's always going to be flipped the wrong way, by the way. And fill the other one as well. Awesome. Now, we have a couple other things in here that we need to do, and this is going to be basically the conclusion of our day here. I need to start creating some trim that goes around the outside of these little windows, right? Because all windows have trim going around the exterior of them. Well, how we can create that trim is pretty easy given the tools that we've been exploring today. If you think about it, the exterior trim that goes around a window is just a whole bunch of rectangles, man. That's all they are, okay? Well, maybe on a new mesh item now, maybe I can use the wall mode with the pen tool to easily create that illusion. I'm going to fire off my snapping engine. But this time, I'm not going to do right angle, straight, or world axis snap. I want to do some vertex snapping. Go fire off the pen tool. Put 2 inches, not 22 inches, 2 inches for my offset. And you can see where the computer is automatically going to snap these things to. There we go. Now, I don't want it to close it because I have plans for that other one here in a minute. There it is. There's the beginning of my window trim. Selecting those 2 polygons and beveling them out, probably about a good inch or so. There it is. There's my window trim.
How did you close the pen?
Huh?
How did you close the pen?
It's an option in the pen tool. There's an option that says closed, and I disabled it so I could only get just basically an upside down U. And we have one more that we need to do. One more that we need to do, and that is going to be the bottom bit. And I'm going to use just the cube tool. I'm using the cube tool just to snap quickly. There we go. I love that vertex snap. And I want to make the height of this guy 2 inches. There we go. I'll drop the tool. Now this bottom bit is actually really important. It looks like I snapped the wrong piece, but that's okay. There we go. The snapping engine is so cool. And I'm going to just scale it out because this bottom bit extends past the frame itself. And I'll simply bevel this out. We'll call it the end of the day. There it is. Simple trim for a window. Now, in all actualities, the sill of your window doesn't look like this. There's actually a small, very subtle slope, and my snapping engine's preventing me from doing that. We put a small slope on window sills for what reason? Does anyone know? Yeah, to make the water run off. And I can do all of these edges. I'll move them together as a unit. That way they're all the same angle. Yeah, there's a small, very shallow little slope there, so the water will run off the sill and onto the ground. Pretty cool, huh? Pretty cool. Now, using the Moto duplication system as a tool, we can very quickly create copies of this window cell because we know that windows 2, 3, and 4 are identical to window number 1, right? If we pair the duplication idea with our snapping engine, we can create some very, very, very high resolution detail quickly. And let me show you what I'm talking about. I'm just going to copy, paste these geometry. I'll fire off the move tool and just start moving it out over here. Okay. Now I'm going to grab all these guys, turn on my snapping engine, fire off the move tool, but I'm going to place the action handle inside that inside corner and then move it along the X until it snaps into the next Windows location. I'll do it again. Copy, paste. Put my action handle in that corner. Boop. Vertex snapping is so cool, man. And I'll move it along the X until it snaps.
Could you use the clone tool with snap?
The clone tool is not going to snap. Yeah. Although you could use the clone tool just to get you a whole bunch of copies and then individually snap each unit to where it needs to go. That'll work. Okay. It's a great, great tool. I like it very much. Now, as we wrap up our class today, I really hope that you now have some ideas that will help you in the construction process of your house. Okay? Use wall mode. Use those Booleans. Take it step by step. You're going to be asked to make 3 different pieces of your house. Of course, the house itself. Okay? From this vantage point, we're going to try to place your entire house in one render. Okay? So from that distance, or use that distance to help you determine how much detail you're going to model inside your house. Okay? I had a student a couple semesters ago spend a tremendous amount of time and energy making the most photorealistic front door I've ever seen. It was a work of art. It was beautiful, right? It was beautiful, and the hardware on it, it was a great recreation. And he was so excited, like, Pat, look at my house. Look at my front door. It's awesome. It looks just like my front door. And I said, yeah, thumbs up. Great job. But let's take the camera out to where we need to render it at and see if we can see all that detail. And he got real grumpy with me all of a sudden. Because basically, the light bulb came on in his mind that he spent 8 hours modeling a front door whose details were not going to be seen in the final render itself. If you look at the banner image here, you can see the front door of this house. Can you see the doorknob? Nope. Actually, if you look real closely, that's the front door. If you look very closely, you can see, or that is a door. I don't know if it's the front door. It is a door. Maybe it's the door to the garage, okay? If you look real closely, you can actually see a doorknob in there. It's there, but it's just like a glorified cylinder, okay? Use this distance, use that render distance to determine how much detail you're going to place on the actual model itself. It's a lot less than you think it's going to be, okay?
You were saying that we do need to add plants and stuff?
Yes. So there's 3 things that you're going to be building. You're going to be building a house. You're also going to be building the landscape for your house, okay? So if you use this image as a guide, you can see that there's a driveway, a sidewalk, a small little fence. Take some inspiration from the cloning and instancing. So we're going to focus on the geometry this week. The next week, we're going to focus on the texturing, okay? So just geometry this week.
So if you're meeting your landscape, then don't worry about making grass and that.
Don't worry. There should be some geometry there that grass will eventually go on, okay? Yep. No floating houses. The render has to feel as though it's grounded in reality, which is why that landscape is so important.
So we're doing the driveway and the fence.
You got it. You got it. Okay? Now, the last thing that you're going to be asked to make are some trees and bushes. Okay? I don't want you to make the trees and bushes. I want you to use the fantastic Moto presets to get you to where you need to go. Let me show you a really, really, really cool thing about working with the Moto. They give you some really great high-quality trees and some bushes that you can and should use for your projects. If you go to the Layout interface, this is where we can find all of our mesh presets. I'm in the Meshes tab down here, and I'm going into the Organic folder. And here it is. Here's a folder here called Trees. And much to my chagrin, there's also one called Rocks, because we've already discovered how much I hate making rocks. So if you go into this folder, here's 5 trees that are ready for you to use. Okay? Simply double-clicking on one will place that tree at the origin of your scene. It's also going to show up in your item list. Okay? If you use, they don't have leaves on them at the moment, but I can show you how to make leaves on your trees next week. It's actually a whole lot easier than you think it is. Okay? They're ready for leaves. They're prepared for leaves, but they haven't been put on there yet.
Where was the meshes thing? I went to layout.
Went to layout down here. See how there's a tab. It says meshes. Are you in there?
Oh, you're in the render area.
No, I'm in the layout tab at the top of the screen.
Yeah, I went to layout, but it's not in the, do I scroll down and find something in there?
Someone may have changed yours. Oh, no. The layout tab. Click off of this. That one. No worries. Okay. So use these trees. There are a couple plants in here too. This is a great way to very quickly populate your environment. The last thing that I'm going to, let's see, house, landscape, trees, bushes. Don't worry so much about this one, but if you're, this is an environment map for your render. Okay. Actually, I'm going to take that off. Don't worry about that one. I'm going to remove that one. That should be placed on next week, so that's an error on my side. And then 1280 by 720, a regular portfolio class render that we've been working with. Okay. This one is kind of deceiving. It's actually much larger than you think it is, but the render makes it feel small. Yeah, but to answer your question, yeah, that's fine. This is a house, right? You don't have to make a mansion. Okay. This person was grabbing the brass ring, right? He really went for it, and he did an awesome job, and now he has a portfolio class image that that he can work with. Yeah, absolutely.
Can I build a hobbit home?
Can you build a hobbit hole? No. No, because a hobbit hole is basically a circular door and some trees and some grass. I want walls. I want walls. Okay. The last thing, and this is my old school modeling practice showing its colors here. You have an additional lab assignment this week, and it's reference collection. I want you to look at some imagery, okay? I want you to do some research on what a house looks like. We all think we know what a house looks like, right? But when it comes time to modeling one, the details are often left at the cutting room floor. The reference will give you a nice starting point. It will be your guide, okay? So I want you to go out, look at some reference, and then collect all these reference images that you found. I think I say at least like 5 or something. I think that's what it says. I can't remember off the top of my head. So find at least 5 reference images, 5 pictures that will guide your modeling process, okay? They are guides. I'm not expecting you to build your reference, because your reference may be the framing of a house, right? Just to get an idea of how things are built. Your reference may be some really cool, architectural details that you want to put in there. It's a starting point. Everyone needs to have a starting point. If you're lucky, your reference will be actual blueprints, the exterior elevations of a house. That's awesome, because now we can just recreate that shape. That's cool too, okay? When you're finished with finding your reference, zip it up and submit it to the Dropbox on D2L. Yes, ma'am. Wonderful. You could go home, take 5 pictures of your house, done. Okay? No, seriously, because that's reference. That's a starting point, right? That's a visual guide that gets you down this path. Okay? Questions on what we're striving to accomplish this week?
No.
Good luck. I'll see you next week. May the force be with you.